After discussing the BCD, we now talk about the gray code, which is another variant of number codes that is used in different applications. And we'll see that in the gray code, the position of the bits does not reflect the magnitude of the number. So what we are used to is we have a number, say 101, and we know that 101, the weight, the position 012 is used to determine the value of a given symbol, and therefore these we call them as 2 to power 0, 2 to power 1, 2 to power 2. On the contrary, the gray code does not use that positional weight to determine the value of a given number that is represented by a gray code. And for this reason, the gray code is termed as unweighted, which is a characteristic of the gray code. In this case, only one bit changes as the count moves from one number to the other. And this is quite significant also. If we count from 000 to 001, there one bit has changed. But when you observe, when you transition from 1 to 2, which 2 is represented as 010, you observe that this bit has changed and this bit has changed. This is in the normal binary code representation. But in the gray code, we can only have one change when we are transitioning from one number to the next. So instead of having two of these changing, you'd actually realize that in gray code, which we'll see how it's done, 2 is represented by 011, meaning that this was already 1, so it never changed, but on the next bit is the one that changed. On the contrary, this represents 2 in gray code, but it represents 3 in normal binary number representation. So that is the characteristic feature that you observe with gray code, which is quite unique from the normal binary representation. We now see the 3-bit gray code for decimals 0 to 7 and how they are represented in both the binary number system and the gray code. So this is the gray code representation, and as I alluded to earlier, you can see that 2 is represented by 011, whereas in the normal binary code, it is represented by 010. So what you'll observe here, there is like they are interchanged between what is representing 3 becomes the one that represents 2, and the one that represents 2 represents 3. So that is what you can observe. But that cannot tell you how to generate the gray code. What can simply tell you how to generate the gray code is simply this feature. We incrementally change one bit, moving from the rightmost to the leftmost. So you can see there was 00 there. The rightmost changed, but in the next step, it never changed. The second bit from right changed, and the third, this is the second, the third. Now in the fourth change, what we see is that this value changes back to 0. So you will see most of the transitions will be happening in the rightmost bit. So let's see what happens when we are transitioning from 3 to 4. What we have observed is that all of these have made their transition from 00 to the maximum, and therefore they are going to remain as they are, as now the next one makes a change. And then we start again the same way we had. The least significant bit changes to 1, and it remains at 1, the next one changes, and finally this last one changes back to 0. So these rightmost, they are making the same transitions as in the beginning. And again, you can see this second one, they are becoming 0011, 1100. So what you'll observe is that we are going to find a method which is quite straightforward of how the gray code is generated. The most important thing to mention is that from one number to the next, we can only have a maximum of 1 bit changing and no more than that. You will see that only 1 bit is changing and not more than 1 bit like it's normally with the normal binary number system. So we want now to talk about an example. And before we do that, what we observe is more or less what I have been discussing, that when we transition from 4 to 5, only one bit has changed. In this particular case, the rightmost bit changes as the count moves from 4 to 5. It can also be observed that the most significant bit of the binary number is the same as the leftmost bit in the gray code. So that is the other thing that we need to observe, that the most significant bit is the binary number, and I think we can go right there up here, is that what you see on the right, this is the most significant bit in the binary number, and this is the leftmost. What we will observe in that case is that they will always be the same. They are going to be always being the same. They do not change. So while the other bits can change, these are always going to be the same.